Hi, we are still in Chapter 3 covering functions, and today we're going to be talking about Section 3.7 inverse functions. In this section, we will verify inverse functions, we will determine the domain and range of an inverse function and restrict the domain of a function to make it one-to-one. We will find or evaluate the inverse of a function, and we will use the graph of a one-to-one function to graph its inverse on the same axes. So first let's talk about what an inverse is. So for any one-to-one function, f of x equals y, a function f inverse of x is an inverse function of f if f inverse of y equals x. First, let's talk about the notation f, and it looks like to the negative 1. This isn't an exponent. This is the notation for inverse function. So we would read this the inverse function of x, or we could read it f inverse of x. We could read it like that. Now, what this means when it says if f inverse of y equals x, what that means is that if I have two functions, we'll say f of x and g of x, these two are inverses if they're inverse if f of g of x equals x and g of f of x equals x. That's what that means. So if I take the composite of two functions and get x, then I know that those two functions are inverse of one another. So in addition to the new notation and reading it f inverse of x, keep in mind that f inverse of x does not equal 1 over f of x. And what we're saying here is don't treat this like a negative exponent. That's not what this is. That stands for inverse. Now, the cool thing about inverses is that they're inverses. So basically, the x's of one function are the y's of the other, and the y's of the function are the x's of the other. So basically, if they say if for a particular one-to-one function f at 2 equals 4 and f at 5 equals 12, what are the corresponding input and output values for the inverse function? So all you're doing is switching the x with the y. So if the function of 2 equals 4, then the inverse function of 4 equals 2. It's basically just like if I had the 0.24 and the 0.512 for the inverse has points at 4, 2, and 12, 5. So basically you're just inverting the x and the y. So for the second one, for f of 5 equals 12, for the inverse at 12 is equal to 5. So just flip-flop the x and the y when they ask you to do that. So given that h negative 1, so again the inverse of h at 6 equals 2, what are the corresponding input and output values of the original function? So pause the video, try this one, and when you unpause, we'll go over it. Okay, so we have inverse h of 6 equals 2. So if we're going backwards to the regular function h, then we're just going to flip-flop those the x and the y. So the function h at 2 equals 6. So just switch the x and the y's. Okay, so how to, given two functions f of x and g of x, test whether the functions are inverses of one another. And this is what I told you earlier on the other slide, is if I take the composites of those two functions and I get x, then they are inverses. So to determine this, we first find the composites. If we get x, if either of the statement is true, then both are true. And g is the inverse of f, and f is the inverse of g. And if either statement is false, then both are false, and g is not the inverse of f, and f is not the inverse of g. So we're going to test the relationship, the inverse relationships algebraically. So even though we don't have to do this twice, I'm still going to do it twice just to show you. So if we want to see if these two are inverses, we find the composite, f of g of x. So f of g of x is 1 over x plus 2, and instead of x, we replace it with what g is. G is 1 over x minus 2. Now, hopefully you see here that the 2's will cancel, and that leaves 1 over x, and 1 divided by 1 over x is the same as 1 times x over 1, which is just x, which means they are inverses, because if one is true, then both are true. But let's just double check just to show you. Okay, so let's do g of f of x instead. So we start with g, 1 over x minus 2, and instead of x, we replace it with f of x, which is 1 over x plus 2. So when we divide 1 divided by 1 over x plus 2, that's the same as saying 1 times x plus 2 over 1, which is just x plus 2. Okay, so all I've done so far is this part. So this part is x plus 2. So now I have x plus 2 minus 2. The 2's cancel, and it leaves x again. So f f is the inverse of g, and g g is the inverse of f of x. So they are inverses of one another. So you guys pause the video and you guys try this one. Alright, so I'm gonna, hopefully you worked through this, so I'm going to work it both ways, just that you can see it both ways, because I don't know which one you did. I don't know whether you did f of g of x or g of f of x, or maybe you did both. So let's start by finding f of g of x. So we'll start with f of x, which is x to the third minus 4, and in here I'm going to put what g of x is, which is the cube root of x minus 4. So when I do a cube of a cube root, they cancel each other out and just leave what's inside, x minus 4, and I get x minus 8. That does not equal x, so this is not, these two functions are not inverse of one another. Now, I already know the answer, and it looks like my my screen was not following along with me, so it just caught up. Okay, so we know the answer is they're not inverse, but just in case you did g of f of x, let's do it that way as well, just to show you you're going to get the same answer. So we start off with g, the cube root of x minus 4, and we replace x with f of x, which is x to the third minus 4. And so that leaves you with the cube root of x to the third minus negative 4 minus 4 is negative 8, and you can't really go any further than that. So either way you look at it, they're not inverse functions. So now we're going to verify that two functions are inverse functions. We're just going to do another example. So determining inverse relationships for power functions. If f of x equals x to the third, the cube function, and g of x equals 1/3 x, is g equal to f inverse. So basically our g and f inverses of one another. So this is the same kind of thing. We're going to do f of g of x, or we could do g of f of x. So let's do f of g of x. So f of x is x to the third we're replacing x with g of x, which is 1/3 x. So then we get 1/3 x to the third would be 1 over 27 x to the third. That's not x. So no, they're not inverses. But we'll try the other way just in case, just to double check. G of f of x, g is 1/3 times x, and x is, in this case, is x to the third. So we get 1/3 x to the third. Again, any way that you look at it, we do not get an inverse function. Alright, so you guys try this one. If f of x equals x minus 1 to the third, and g of x equals cube root of x plus 1, you guys find the composite function and determine whether they are inverses of one another or not. Okay, so let's start by finding f of g of x, and f of x is really x minus 1 to the third, and I should have left more space there, x minus 1 to the third, and x in this case is really the cube root of x plus 1. Okay, so I can do the cube root of x plus 1 and minus 1 cancel, and then that's taken to the third power. I get x, so it looks like they are inverses, but let's double check it. Let's do g of f of x. So we start off with g, which is the cube root of x plus 1, and instead of g, instead of x, we're going to put in x plus 1 to the third. And the cube root of x plus 1 to the third, that cancels out and leaves x plus 1. I'm sorry, I wrote that wrong, didn't I? That should say x minus 1. So that cancels, it leaves x minus 1 plus 1, and we get x. So they are inverses. So now we're going to talk about domain and range of inverse functions. So domain and range of inverse functions, the range of the function f of x is the domain of the inverse function. And the domain of f of x is the range of the inverse function. So basically, the domain is the range of the inverse, and the range is the domain of the inverse, and vice versa. So, if the function is 1-to-1, write the range of the original function as the domain of the inverse, and write the domain of the original function as the range of the inverse. So if you're asked to find the domain of an inverse function, you write the range of the regular function as the domain of the inverse. And then if they ask you to write the range of the inverse function, then you write the domain as the range. That makes sense. So again, just like earlier we were flip-flopping the x's and the y's, now we're flip-flopping the domains and the ranges. Now, okay, so if the domain of the original function needs to be restricted to make it 1-to-1, then the restricted domain becomes the range of the inverse. So what that means is something like absolute value. It's not 1-to-1, okay? It's not 1-to-1. So before I find the inverse, I could make it 1-to-1. So how could I make it 1-to-1? Well, here, let me do it this way. Alright, how do I make it 1-to-1? I restrict it to just this part right there. So the domain here would be from 0 to infinity. That's the domain. So the domain for the inverse, that would be the range of the inverse from 0 to infinity. So when it says the domain of the original function needs to be restricted to make it 1-to-1, then the restricted domain becomes the range of the inverse. So if we have to restrict something like absolute value in order to make it 1 to 1, then that will become the range of the inverse function. Okay, so the domain of function f is 1 to infinity. The range of the function f is negative infinity to negative 2. Find the domain and range of the inverse function. So for the inverse function, the domain is the range of the function, and the range of the function is negative infinity to negative 2. And then for the range, that is the domain of the function, which is 1 to infinity. Okay, so we're going to stop here, and we're going to pick up with this next try it in the next part of 3.7.